Okay, so we move to the second part of the enlargement. Before I move on, just want to test you again. Do you still remember what is the formula for the scale factor? Still remember the formula of the scale factor? That is the length of?
Image over object.
Yes, length of side of the image over the length of side of the object. Usually, I just simplified it by saying this is the image length over object length. What about the other one? There are two formula, right? Do you still remember the other one?
Distance from the center
Yes,
to
very
the
good.
vertex of the
Distance.
image.
Correct. Distance of the image from the center. So it is always the image on top from the center. I don't write down lah, so you know lah, huh? And then this one is the object, distance of the object from the center. Okay, so we move on to this example over here, the mind mobilization. Okay, during an enlargement, you look at the paragraph given. The length of the corresponding sides are constantly proportional. So this one you know, right? When there is an enlargement, the corresponding sides are constantly proportional. What is the relation between area of the image and the area of the object of an enlargement? So what happened to the area? You know that the length is proportional already, but then what about the area? So they ask you to do this exercise over here, given you the table, then you have to complete it. So the first one is already given. When the scale factor is equal to 2 with the area of the object, which is 1, the area of the image will be 4. So we look into this one. This one is given in your book. They ask you to go through it. So I make it smaller. Okay, so you can see this one is given based on what we have over here. So area of object is 4. So you fill in this part over here. Area of image is 4, this one. Area of object is 1. Okay, therefore 4 divided by 1, you get a 4. That is the ratio of the area of the image to the area of the object. So when we use the k given is actually 2, okay, because you can see from here, the scale factor is equal to 2, okay? So k squared will be 2 squared, 2 in bracket squared equal to 4. Why in bracket? Because we have a scale factor that is in negative form later on. That's why you have to put it in bracket. Okay, now if you look at scale factor is equal to 3. So I'm going to move on 3. Can you see that? So when I move on to 3, the value of the area of the object is still the same. It is 1. And then the value of the area of the image will be 9. Where does the picture go just now? Oh, here. Okay, you see it becomes 9. And then the ratio of the image over the object will be 9 over 1. So we get a 9. So the k squared is 3 squared. 3 squared is equal to 9. Okay, so this is one of it. Now, I'm going to choose other, which is in negative. For example, negative 2. So I'm going to move backward to get a negative 2. So this is negative 2 right now. Okay, the area of the object is still a 1 and 4 for the image. So write down, this is 1, this is 4. So the area of the image over the area of the object will be 4 over 1 equal to 4. And then this will be negative 2 squared equal to 4. So from here, they actually related to the next formula that you are going to get, whereby the area of image is equal to k squared times area of object, this one. Okay, so you can see the area of the image on this part is actually equal to k squared. K squared is equal to 4 multiplied by area of the object, 1. Or to make it easier for you to remember, you just compare with the scale factor that we have just now. It is the image length over the object length, right? So when it comes to k squared, you just change it to area because squared represents area. So area of the image, or image area over the area of the object. They are the same as this one. Okay, So when you want to find out area of image, it is k squared multiplied by area of the object, just like this one, multiply area of the object. Are you okay?
Okay, madam.
Okay, so we move on to find out the answer for one of the example here, example 12. Anybody volunteer to read? Anyone volunteer to read?
Me, madam.
Okay, go ahead.
Example 12, right?
Yes, correct.
The table below shows the different values of area of the object, area of the image, and scale factor under enlargement. Complete the table.
Okay, thank you very much. So now if you look at A over here, we are given the area of the object, 5 centimeters squared, and then area of the image is 45 square centimeter. Okay, so we were asked to find out the scale factor. Easy, you already know, right? The scale factor is equal to K. But then you just now, you have learned that K squared is equal to the image area over what? Do you still remember? Over the
Object area.
very good, object area. So we are going to apply this one to find out the answer for the K. Okay, so start from the K squared is equal to the image area that we have over here is 45. So over 5. Okay, so first of all, we are going to simplify it. 5 times 1, 5. 5 times 9, 45. Meaning that K squared equal to 9. So K is equal to square root of 9. Okay, so over here, when you found out the square root of 9, the value of the scale factor can be in positive and negative, right? Therefore, we have two answers for this one. Square root of 9 is 3, or it can also be negative 3. Okay, so we write down using the word or, it would be better lah. 3 or negative 3. So we found out the answer already. Over here, it can be 3 or negative 3. First one, okay, right? Easy. Okay, second. You're given the area of the object, which is 12 units squared, and then you're given the scale factors. So you just need to apply this one. Since the scale factor is already given, k squared, right? So you just write down 7 over 2 in bracket squared. So image area is the one that you have to find. You just write down area of the image over area of the object is given, it is equal to 12. So now we can get the answer for the area of the image already. It is equal to this times this, right? So 7 squared is equal to 49. 2 squared is equal to 4. So you just need to multiply by 12 and then simplify it. So 4 times 1, 4. 4 times 3, 12. 3 times 49, 3 times 50 is 150, right? So you minus 3, so you get 147 units squared. You follow the same unit, okay, because it is in unit here. Can? Any problem, class? No problem, I just
No
move
problem.
on. Okay, I move on to the third one, C. So you were asked to find out the area of the object, given the area of the image and also the scale factor. Okay, remember k squared is equal to area of the image over the area of the object. So I'm going to write down the k squared is negative 4 squared is equal to the area of the image, 100, over the area of the object. So if I'm going to find out the object area, I'm going to use the 100 to divide by negative 4 squared. So 100 divided by negative 4 squared. 4 times 4, 16, right? Negative 10, negative, positive. So 100 divided by 16. Okay, then you do your calculation. 100 divided by 16 equal to how much?
6.25.
Oh, thank you very much. 6.25. What is the unit given? Okay, square meter. So that is example 12. Okay, this one is simple, right? You just need to memorize the formula to find out the area. Okay, now we move on to how to solve problem involving enlargement. Okay, this is a long question over here. Anyone volunteer to read? No? If not, then I'm going to call you. Dania, are you there? Dania? Daniel, no sound. Amir, are you there?
Yes, madam.
Okay, can you read, Amir?
Okay. Example 13, in the diagram on the right, trapezium AEFG is the image of trapezium ABCD under an enlargement at center A. Given that the area of the colored region is 168 centimeters square, calculate A, the scale factor of the enlargement, B, the area in centimeters square of trapezium AEFG.
Okay, thank you very much. So first, you look at A here. We need to find the scale factor of the enlargement. After that, you need to find the area of trapezium AEFG, meaning the area for the whole diagram here. Okay, so first, you need to see all of the given information here. In the diagram, so trapezium AEFG is the image. So which one is AEFG? Big one, right? The big one is the image. So I'll write down first. Let me use lighter color. Okay, this one is to take here. This is the image. Okay, after that, trapezium ABCD will be the object, this one. Under an enlargement at the center A. So remember, this is the center. Okay, given that the area of the colored region is 168, meaning this region over here is 168 square centimeter. Okay, calculate the scale factor of the enlargement. So to calculate the scale factor, you are just going to use the length of sight because you are given the length of sight for this object and also image already. So easy, we just apply that one on. Okay, so K is equal to AE over AB. Can you see that? So the length of A to E will be 20 plus 16. 20 plus 16, it is equal to 36. And then over the object over here, it is equal to 20. So we simplified it. When you simplify it, divide by 4, 4, 9, 36, 4, 5, 20. So we will get 9 over 5 as a scale factor. Okay, so first one is complete. Now we need to find the area of the trapezium AEFG. We need to find the whole image area. Okay, so to find the image area, you are going to apply this one. How to get this? This is the image area minus the object area. Image area minus object area. So we get the area which is equal to 168. Okay, I write down now. So in the book, they make assumption for you, something like let, okay, for example, let L1 equal to image area or object area. Let me see which one you need to use. Okay, let L1 equal to object area. And then let L2 equal to image area. Okay, I repeat again. So you're given 168 for the colored region over here, this part. If you want to get the answer for the trapezium AEFG, the big one, AEFG, okay, first you need to find out the equation first. That will be the AEFG minus the ABCD equal to 168. So that will be the L2, the image area, minus the object area equal to 168. You're okay, right? So over here, we are going to continue the L2 because L2, we don't know how much is the area. That is the image. So we cannot do anything. But then we can minus the other L1. L1 is the object area. Okay, if you still remember, K squared equal to image area over object area. So L1 is the object area. We are looking for the object area. So the object area will be equal to image area over K squared. Can you see that? becomes like this. Object area equal to image area over K squared. So for the L1 that we have over here, because L1 is the object area, right? This one, object area. So the formula will be object area equal to image area over K squared. Okay, so image area we also don't know, but then we know that the representation for image area is equal to L2. So I'm going to use L2 over the scale factor. Okay, the K2 area of the scale factor, that will be 9 over 5 squared, the one that we get earlier, this one. Okay, and make it equal to 168. Okay, so continue from there. L2 minus, so L2 over 9 over 5 squared is actually equal to L2 multiplied by 5 over 9 squared equal to 168. So we complete this part first. It is equal to 5, 5, 25, 25 over 81, L2 equal to 168. Are you okay so far?
Okay.
Yes.
Okay, yeah? So L2 minus this, they are having the same unknown right now. You see L2 and L2, so we can minus already, which means the first part over here, this one is 81 over 81. Minus 25 over 81. So 81 minus 25, we have a 56 over 81 L2. Do you know how I get my 56? Yes, right, because this one L2 is 81 over 81. So it's a 1 L2. So 81 minus 25, we get this one, minus this, we get a 56. Okay, so it's equal to 168. Then we can get our image already. It is equal to 168. So send the 56 over 81 to the right, becomes multiplied by 81 over 56. Okay, so you are going to get your area of image is equal to how much, class? Let me try.
243.
Yes, thank you, because this is 1, this is 3. 3 times 1, 3. 3 times 8, 24. Okay, 243. So the area of the image, just re-answer again. The area of trapezium AEFG is equal to 243 squared centimeter. So we just rewrite again down there. Are you okay?
Yes.
Yes, huh?
Madam,
Yes.
Madam, can you repeat from the L2,
From where?
the 56 over 81?
From where? Oh, okay, can, sure. So this part here. Okay, I redo this part. I know you will have a bit of confusion over here. Okay, so I repeat here. So continue from this line. The second line will be L2 minus. So over here, 5 squared means 25. I write down. 9 squared means 81. Oh, so times means you can exclude the multiplication and just write down L squared. Okay, it is just like 2 times A. So it is 2A. You learned this before. Okay, equal to 168. Okay, now we continue here. How to minus 25 over 81 L2? Because both of it is having the same unknown. Just like you have learned this before. A minus 1 over 2A. How do we minus? Because this is 1, right? So we got to make them the same denominator. Therefore, I'm going to change a 1. Becomes 2 over 2A. 2 over 2 is a 1, right? If I simplify, it's the same thing. So the purpose, I make it becomes 2 over 2 so that I can minus the 1 over 2 on the right. Okay, so it becomes 2 over 2A minus 1 over 2A. So 2 over 2 minus 1 over 2, and then I have 1 over 2. There is a meaning over here. That is what I apply on L2. So it is 81 over 81. Since that this is 81, we depends on this number to get the number in front for this one. Okay, so 81 over 81 L2 minus 25 over 81 L2 equal to 168. Therefore, we can minus the numerator already. 81 minus 25. So 81 minus 25, you can see. Okay, this is 11 minus 25, we have a 6. This becomes 7. 7 minus 2, we have 56. So we get 56 over 81 L2 equal to 168. Are you okay now?
Yes, okay.
Yes, huh? Then you just continue with finding the L2 is 168. Originally, it is divided by 56 over 81. So we need to change it to multiplication. 81 over 56. So you can see the common number here. 6 times 3 is 18. So most probably, this times 3 times you get 168. That is correct. Okay, so 3 times 1, 3. 3 times 8, 24. Okay?
Yes.
Okay, so we move on. Okay, so this is the second last example for the enlargement. Okay, we move on to the last example here. Okay, last example is about the stem association. Azrina, can you read? Azrina,
Yes,
can you read this example here?
the diagram below shows a rectangle logo drawn by a member of STEM association. On the School Entrepreneur Day, the STEM association intends to put up a banner at their store. The banner is designed based on the enlargement of the logo. If the area of the banner is 0.8 meters square, what are the measurements of the length and width in cm of the banner?
Okay, thank you very much. So we go back to the question again. You see, this diagram here, it shows a rectangular logo drawn by the member, this one. Can you tell me which one is the length? From this logo?
15 centimeters.
Yeah, 15 centimeter. This one is the length. Which one is the width?
12
12
centimeters.
centimeters.
Very good. This is the width. Okay, you need to determine first. So now look at the next line. On the School Entrepreneur Day, the STEM Association intends to put up a banner at their store. The banner is designed based on the enlargement of the logo. Okay, so based on the enlargement of this logo over here, can you tell me this logo over here is either equal to image or the object? Which one? Object or logo? Object or image?
Logo object.
Yes, very good. This is the object, so I write down. Remember, the logo is the object. Now, if the area of the banner, why so many WhatsApp? Sorry, I close it. Okay, so if the area of the banner is 0.8 square meter, okay, that is the area. So now they involve the formula of area. What are the measurement of the length and width in centimeter of the banner? Okay, so you can see the area given is in meter squared, but then they were asking for centimeter. So there is one thing that is already different, whereby the unit measurement is different. Okay, can you tell me 1 meter equal to how many centimeter?
100 centimeters.
100, right? Okay, if I want to get 1 square meter is equal to how many centimeter? 10,000 square centimeter. Okay, now I'm going to find the area of the logo first. This area, the object here. So to find the area of the logo will be easy, right? Because you just need to use the length multiplied by width. Write down properly. Area of logo is equal to 15 times how much?
12.
Okay, 15 times 12. So we will get a 180 from here, 180 square centimeter following the unit. So therefore, the area of the banner is equal to 0.8 square meter. This one, right? Okay, we are going to write down area of banner is equal to 0.8 square meter. So we need to change it becomes square centimeter. We need to make it the same as the one on top over here. So 0.8 meter squared. You see, we have 4 zeros over here. So I'm going to move 4 zeros to the back. Okay, 1, 2, 3, 4, and I just add on. Therefore, it is equal to 8,000 square meter. Okay, that is the area of the banner. Are you okay so far?
Okay.
Yes,
madam.
Now, from these two here, can you tell me which one is the area of object, which one is the area of image? This is area of what?
Object.
Very good. So the other one will be?
Image.
Yes, correct. So now from there, then we can continue already by finding the scale factor. Okay, so k squared, our formula is the area of the image over area of the object. So area of the image is 8,000 over the area of the object is 180. So I'm going to simplify over here. So cancel the 0 with the 0. Okay, 9 times 2, 18. 2 times 9, 18. Okay, I'm going to use 9. 2 times 9, 18. Okay, after that, 2 times 4, 8. 2 times 0, 0. So we get a 400 over 9. Then from there, we can get the value of the square root of 400 over 9. So you got to make sure the number that you get must be a perfect square. Okay, so k is equal to square root of 400 is 20. Square root of 9 is 3. So we get the value of the scale factor already. Okay, this one you are fine, right?
Yes.
Yes.
Okay, now we go back to what is the requirement in the question. Okay, what are the measurement of the length and width? This is the requirement of the question. You need to find the length and you need to find the width of the banner. Meaning that after the enlargement, you need to know how much is the length and how much is the width here. Okay, so we continue. To find out the length, you already learned from the scale given. Scale factor is equal to the length of image over the length of object, right? So I'm going to apply on that one. K is the image length over the object length. I rewrite lah, image length over object length. So the K that we got earlier is 20 over 3. I'm just going to replace it. 20 over 3 is equal to so we already have one of it given, the image length, the object length, which is 15. So we are going to find the image length first. Image length over 15. Therefore, to find out the image length, it will be 20 over 3 times 15. So just do cancellation. 3 times 1, 3. 3, 5, 15. 5 times 20 equal to 100 centimeter. Okay, right? So we got the image length already. This one, complete. Now we need to get the width. So if you want to find the width, you can do like this also to get the answer. But you can save the time right now since you already have the image length. Okay, because you have the image length over here as 100 centimeter already. So we are going to use the width. Remember the area to find out the area. For example, the area of the object that we want to find here is equal to length times width. That is the very basic one. So now you already have the length, you already have the area. So we just need to find the width. Therefore, the width is equal to area over length. How much is the area?
8,000.
Yes, very good. You got it from here. Okay, so the image area 8,000 over the length that we got for the image just now is 100. Cancel 0, so the answer is 80 centimeter. So we answered both of the question already. Okay, the measurement of the banner over there for the length is 100 centimeter and then the width is 80 centimeter. Are you okay, class?
Okay.
Yes, madam.
Yes, do you have any question?
So far, no question.
So far, no question. Okay, good. So in your exercise for this one, the enlargement, let me see which one should I give to you. It's actually 5.2 because you already continue from 5.2C. So I want you to do the exercise on 5.2D and also 5.2E. Okay, 5.2D is a very simple question. And then 5.2E, we have 4 questions. So the questions is quite long. You just finish up all of this. Okay?
Okay.
All right, so in the next lesson, we are going to continue with combined operation. So hopefully you remember some of the transformation that you have learned. Combined transformation. What are the transformation that you have learned previously? Do you still remember?
Rotation,
Yes, rotation. What else?
reflection,
Very good. One more. Start with T.
translation.
Yes, translation. So you are going to apply 3 of these, including the enlargement that you just learned, to settle this combined transformation. Okay, before we end the lesson, what did you learn today? One more time.
How to find K-square.
Pardon?
How to find the K-square.
Okay, correct. How do you get the K squared? So K squared is the scale factor squared. That is the area of the image over the area of the object. It's up to you which one for you will be easier to memorize. If easier for you to memorize this one, area of image equals to K squared times area of object, then you memorize this. If it's easier for you to memorize this, then you just go ahead with this one. Okay, so in this enlargement, you learn how to find K, you learn how to find K squared. Okay, that's all for this enlargement. So we end our lesson today.
Okay.
Okay. See you next week then.
Thank
Bye.
you, madam.
Thank you.
Bye-bye.
Bye.
Thank you, madam.
Welcome.